Hi, my name is Krishna Maran and this is my Physics Lab 4 report. So in this lab, we examined a spring and a mass system in which the mass swings in an arc while oscillating on a spring at the same time. So the main equations we used for this were the kinetic energy, which is 1/2 mv squared, the gravitational potential energy, which is mass times gravity times the y position, and the spring potential energy, which is 1/2 times the k constant times s squared, which is the length. And then the total energy are all three of those added together. Then for F net, we used force of gravity and the spring force, which is mg times a -1, and then k times the length times L hat times a -1. For F net would be these two added together. So now, using the code and the tracker data, we compared the predicted and the observed mass and how it moved while it was on the spring. Now for the observations and the data. The potential energy is in green and red. The spring potential is in green and the gravitational potential is in red. Now these two added together will equal the blue curve. So as you can see, for every loop, when you add the green and the red, it will equal to whatever the blue curve is at. And that is also constantly changing throughout the graph. And the reds and greens are also changing ever so slightly as well. And then in the orange, it is the total energy. In this case, it is always zero because the potential energies plus the kinetic energy is always zero in this case. Therefore, the energy principle is correct and it works in this case since the total energy is constant and it is always added up properly. Now, as you can see in the position versus time graph, the predicted position is exaggerated by about 0.01 meters, as you can see in the oscillation. However, the peaks and the troughs are at the same time, so that means the times are accurate. Now, to continue the observations and the data, I found the period of oscillation in the x and the y direction using the two graphs from tracker that I extracted in the x position and the y position versus time. So for both of them, I used the peaks to find the period of oscillation. So for each pair of peaks there are, in order, I subtracted the two times from each other and I found the average of all those times. So there was 5 times that I added together and divided by 5 to find that average, which in the x direction was 1.615 and in the y direction it was 1.424. Then to the right here, this is the video that the code creates of the predicted, which shows that the spring moves in a rectangular fashion by the end of it, since it is going just about in the same way in the y direction and the x direction, just a little bit longer in the x direction than the y direction. Now for the code. So first I did the mass and the initial position. So the mass was 0.402 kilograms and the initial position was 0.113 in the x direction and 0.630 in the y direction, and these both were not positive. Then I found the force of gravity and the force of the spring, which I did by finding L and L hat, which was the ball position minus the spring position, and then L hat was that divided by the magnitude of L. The magnitude of L minus L naught, which is the relaxed length of the spring, was equal to the spring length. I solved for the k constant and L naught so for the k constant I used the period, which was equal to 2 pi times the square root of m over k. And since I had all the other values except for k, I solved for k and I got k to be 6.83. And then for L naught, the relaxed length of the spring, I used the force of gravity is equal to the spring force. And since it is just mg times the k constant times s times L hat, I split up s into L minus L naught. And since we have all the other values, except for L naught, I solved for L naught and got 0.123. So I inputted these into the proper formulas into the code. And for the change in energies, all I did was the final energy minus the initial energy for the kinetic and the gravitational potential, the spring potential, and the total energy. And I just inputted the equations we talked about in the introduction into the code for the final and initial energies.